Lesson 12, Precalculus. This is Chapter 2, Section 4, Complex Numbers. What we're going to learn how to do here today is use an imaginary unit I to write complex numbers. Add, subtract, multiply complex numbers. Use complex conjugates to write a quotient of two complex numbers in standard form. Find complex solutions to quadratic equations. Complex numbers are used to model numerous aspects of the natural world, such as impedance of an electrical circuit. So they use it in electricity, the letter I. If you want to be an electrical engineer, you're definitely going to need to know how to do it. All right, it says some quadratic equations have no real solutions. For instance, the equation x squared plus 1 equal to 0. When you move the 1 over, you get a negative 1. So they wanted to make answers to it. So because of this deficiency, mathematicians created an expanded system of numbers using an imaginary unit I. So x is equal to plus or minus the square root of negative 1, and the square root of negative 1 is I. So plus or minus I. So on the next page here, we've got the base I is the square root of negative 1. If you have I times I, or I squared, it's equal to, so we got I. The letter I is just I to the first is I, and then I squared is negative 1. I squared is equal to negative 1. And then if you have I to the third, that's 2 i's and 1 more. We know that I squared is negative 1, so it's negative 1 times I, or negative I. So 3 of them is negative I, and if you have 4 i's, you have I squared times I squared, and we know I squared is negative 1, so negative 1 times negative 1 is just positive 1. Then if you've got 5 i's, so 4 i's and 1 more, we know that 4 i's is 1 I. 4 i's we know is the number 1, and then times I, so it's just I. And then 6 i's, again 6 i's would be 5 i's and then times I. We know 5 i's is I, and then times I is I squared, and I squared is negative 1. And then I to the 7th is 6 i's and 1 more, and 6 i's was negative 1. So that makes negative 1 times I, or negative I. And about now, everyone usually says, whoa, wait a minute. It's repeating over and over again. Yes, it is. It just keeps repeating. So it went I, negative 1, negative I, 1, and then it repeated back to I, negative 1, and then negative I, and then 1. And then it repeats again. It goes I, negative 1, and then negative I, and then finally 1. So it repeats every 4. So what you can do, now I'll show you on the calculator here. It's pretty good at doing small amounts of i's. So the letter I on your calculator is down here underneath the decimal is a letter I. So you can type in, let's do it. We did I to the 4th here a second ago. So I to the 4th is just 1. And then I to the 3rd is negative I, and I squared is negative 1. And you can do I to the, let's see if it'll do it to 100. It might. Yep, it's 1. But if you get like, I think over 100 or so, I don't know exactly when it stops, but at some point it stops. So I think if we do I to the 150, I don't think it'll work. It does not. So when it gets to be a really big number, you've got to kind of break out how many there are to the 4th. So like if you have I to the 150, what you want to do is break out groups of 4 of it. So divide it by 4 on your calculator. So 150 divided by 4 gives you 37.5. So that's I to the fourth, and then to the 37th, because 4 times 37. So 150 minus 4 times 37 leaves you with 2 left over. So I squared. So I to the fourth again is 1. So 1 to the 37th is still 1, and then times I squared. And we know that I squared is negative 1. So the whole thing equals negative 1. So you got to break it out by groups of 4. But overall, your calculator is going to help you out when there's under 100 of them. We are going to use complex conjugates a lot with imaginary numbers in order to get rid of the I. So a conjugate, remember, is different signs. So if you have, for example, 3 plus 4i, the conjugate of that is 3 minus 4i. Instead of plus, it's minus. Or if you have maybe 8 minus 6i, the conjugate of it is 8 plus 6i. All right, so doing addition and subtraction down here with imaginary numbers, we have a minus here. So it's 11 minus 2i, and then minus a negative 3, so it makes plus 3, and minus a plus 6i makes minus 6i, or you could say you distributed the negative 1 across it. Negative 1 times negative 3 was 3. Negative 1 times a positive 6 is negative 6. So combining the numbers, 11 plus 3, you have 14, and then combine the i's. Negative 2i and negative 6i is minus 8i. So the whole answer is 14 minus 8i. And I want to show you the calculator actually will do that for you, which is kind of fun. You can put the whole thing in your calculator and it'll say 14 minus 8i. So we've got 11 minus 2i, and then minus, parenthesis, negative 3 minus 6i, and you get 12 plus 4i. What did I type in wrong? Oh, shoot. So second enter, that was supposed to be a 3. And that was supposed to be a plus. Son of a gun. There we go. So 14 minus 8i. All right. All right, next one. Negative 1 plus 8i plus 8 minus 5i. There's no minus there to distribute, so we can just combine. It's negative 1 plus 8, which is 7. Positive 8 minus 5 is 3. So the whole answer is 7 plus 3i. Again, you could put in your calculator. We got parentheses negative 1 plus 8i, and then plus 8 minus 5i gives you 7 plus 3i. All right. It's a little more interesting when we're multiplying them. Let's see if we multiply here on the next page. Yes, we do. It's a little more interesting. All right. So multiplying these out, we're just foiling them. You treat them like it's kind of like the letter X. So you're just foiling it out. So we have 6 minus 2i times 2 minus 3i. So foiling it out, 6 times 2 is 12. And then 6 times minus 3 is minus 18i. 2i times 2 is minus 4i. And then negative 2i times negative 3i is plus 6i squared. That's the ugliest 4. All right, so combining, we have 12 and negative 18i and minus 4i. Same signs, add them up. Negative 22i. I squared against negative 1. So that's 6 times negative 1, or negative 6, or minus 6. So the whole thing makes 6 minus 22i. Or again, you could have put it in your calculator. You're going to get that answer too. So we got parentheses 6 minus 2i, and then 2 minus 3i. You get 6 minus 22i. Okay, next one. 4i times 8 is 32i, and then 4i times 5i is plus 20i squared, and that I squared against negative 1, so it's 32i minus 20. So technically, by the definition of how you write things in standard form, you're supposed to put the number first and then the I. So this would be the standard form of it. Negative 20 plus 32i. And again, your calculator would have done that too. On the next one, you're going to FOIL it out again. We got multiplication going still. Radical 3 times radical 3 is just 3. And then radical 3 times minus radical 15i is minus radical 45i. And then in the middle here, we got a plus, so it's plus radical 45i. And then positive times a negative is negative 15i squared, because there's I times the I. The I is not under the radical there. So I times I is I squared. Again, that makes negative 1. These are gone. They're opposites. So we're left with 3 plus 15. So the answer to the whole thing is 18. On the next one, we have got 6 plus 7i squared. I'm going to star it. A lot of you would say it's 36 plus 49i squared, or 6 minus 49, and then you'd lose your middle term. You always forget your middle term. You have to write it out. When there's a plus and it's squared, it's 6 plus 7i times 6 plus 7i, so you can get that middle term when you FOIL. So 6 times 6 is 36, and 6 times 7 is plus 42i, and 6 times 7 there is plus 42i. 7 times 7 is plus 49i squared, so that gives us 36, and then 42 and 42 is 84i, and then that's going to be minus 49, because again, I squared is negative 1, so it's 49 times negative 1, which is negative 49. So combining then, negative 49 and 36, you get negative 13 plus 84i. Again, the calculator would have also done that for you. Okay, at 52 it says write the quotient in standard form. Now this is not in standard form because it has the letter I in the denominator. It says negative 5 over 2i. You're not allowed to have a radical in the denominator, so we're going to rationalize it by just multiplying the top and bottom by the letter I. Just like we did when we had radicals. If there was a radical in the denominator, you just multiply by it on the top and the bottom. It's like multiplying by the number 1. You can do that. So it gives you negative 5i over 2i squared. And again, I squared is negative 1, so that makes that negative 2 on the bottom. Our two negatives are a positive, so it's positive 5 over 2i. This one, we want to get rid of the I down here. So to do that, you're going to need to multiply by the conjugate of it. So multiply by its minus, so the conjugate of it would be plus. So you're going to multiply the top and bottom by 4 plus 5i. So multiply across by the 2, and that gives you 8 plus 10i. And in the denominator, when you FOIL it out, you get 4 times 4 is 16. And then 4 times 5 is plus 20i. The middle term is minus 20i. And then the last outer term, negative 5 times positive 5, is negative 25i squared. So that leaves you 8 plus 10i divided by, that's gone, divided by 16 plus 25, because again, I squared is negative 1, so you got 16 plus 25. So add them up, you got 41, so it's 8 plus 10i over 41. And I don't care if people leave it like that, but I think in standard form you're supposed to break it up. It doesn't really matter. It doesn't really come up that much, but that would be standard form of it. You got the number and then the imaginary part over there. Okay, writing complex numbers in standard form. Perform the operation and write the result in standard form. So this is what we were doing before. It's just now we've got some radicals here to add to the fun of it all. So cleaning it up here, 72, it's negative 72. So the first one here, we have negative 12 minus radical 72i. I'm going to go ahead and take the negative out. And then plus 9 plus the square root of 108i. All right, 72 is 36 times 2. So you got a 6 you can take out. So it's minus 6 radical 2i. And 108, surprisingly, it's got a 36 in it too. For 108. Well, let's see, it's got a 9 in it. So 9 times 4. No, it's got a 36 in it. 36 times 3 is 108. Yeah. So you can take a 6 out of that too. So plus 6 radical 3i. So the numbers, negative 12 and 9 is negative 3. And then we have, well, we'll do a plus. We have 6 radical 3 and then a minus 6 radical 2, and they were both times I. So I combined the numbers to get negative 3, and then to put the imaginary part together, so technically it's all in standard form. I put the 6 radical 3 in there and the 6 radical 2 in there, and then the I on the end. They're both times I. All right, 65 is interesting. I don't think your calculator will help you with it. Put the I outside it, so it's radical 6i and radical 2i. So the radicals make radical 12i squared, and 12 is 4 times 3, so that's 2 radical 3, and it's negative because I squared is negative. So the whole answer is negative 2 radical 3. All right, complex solutions of a quadratic equation. Solve the quadratic equation. All right, so this has got imaginary solutions on it. So let's do it here. So again, the quadratic formula, negative b plus or minus radical b squared minus 4ac over 2a. Our b, we got a, we got b, we got c. So negative b, so it's negative 6, so it makes positive 6 plus or minus b squared, or negative 6 squared, positive 36, minus 4 times a times c over 2 times a. So it gives you 6 plus or minus, so 2 times 9 is 18. So underneath the radical there, we've got 36 minus 4 times 9 times 37. You get negative 1296. And negative 1296 is shockingly, 1296 is actually a perfect square. It is 36, but it's got the letter I on it, so that makes it 6 plus or minus 36i over 18, so you could split it then. So it's 6 over 18 plus or minus 36 divided by 18, which is 2, and 6/18 is a third. So that would be the whole answer to it. 1/3 plus or minus 2i. All right, I'll see you for the next lesson.